Let's talk about proportions one more time here. Proportions are just a couple of ratios set equal to each other. So you'll notice up top here, we've got a ratio of A to B and C to D. Now, I've made a previous video about solving proportions for fairly simple proportions, similar to the one down here at the bottom. One opportunity to solve a proportion is just look at it as a couple of division problems. So if I want to get x by itself, I could simply multiply by 6, right, on both sides and cancel those sixes on the right. Now that's not a bad way to go. That would be a really simple way to solve this problem. But along those lines, sometimes proportions are a little more tricky, such as the one on the right there. And so let's take a look at a little different method of solving what we call cross product property, or what we often call in math cross multiplying. Basically looking at your proportion and saying, hey, instead of A divided by B, kind of like we did with the 6, what if I multiplied this side by B and I multiplied this side by B, right? And then at that same time, since that's going to cancel the B's on the left, why don't we do the same thing to the D value down here at the bottom here? What if I multiply this side by D, right? And I multiply this side by D, and we're going to cancel those variables on the right. And notice what we end up with. We have D times A and C times B left over, and we don't have any more division to worry about, right? It just makes a quick and easy way to solve a proportion. So let's go back. Let's try that with our simpler problem down here at the bottom, right? Let's try that out. Okay. And let's cross multiply. Basically what we're going to do is take the bottom of the right side, so take that 3, and we're going to multiply it over times the top of the right side, right? So bottom on the left times top of the right, or basically 3 times x. That's going to be equal to, well, now let's do the same thing on the other side. What if we take the bottom of the right times the top of the left? So I'm going to take 6 times 16. Again, we got rid of that division, which is a nice thing. I can go ahead and find that number. 6 times 16 would be 96. And now we just have a simple equation to solve. If we're multiplying, let's divide away that 3 on both sides. That's why you often also hear people refer to this as cross multiply and divide. Because once you get done with your cross multiplying, often there's just one step left to go, right? We can get rid of, right, those numbers, like those 3's. And now 96 divided by 3 would be 32. And again, you could always take that 32, put it back in your equation. Pretty easy to check here, though. If 3 times 2 is 6, then 16 times 2 would have been 32 over here, right? Easy one to check on there. Now, a little bit more complex over here at the right, though. So now what we want to do is use that cross multiply idea. It's a great method, especially when there's variables in the denominator, or especially when you've got a quantity like an x minus 3 down here. Cross multiplying just helps you stay organized. So let's go ahead and do it. We've got 8 on the upper right times x minus 3. Again, I always like to write my number in front of my quantity there. And then the same thing over here, we're going to have that 4 times x, right? So again, we always write our numbers in front of our variables as well. No more division going on, so now we just need to clean it up a little bit. So over here on the right side, I'm going to go ahead and distribute. Okay, let's take 8 times x, which again is 8x. Let's take 8 times negative 3. So we have a 24. And again, we still have 4x over here at the right. Now it's your option which way you want to move your variables, which way you want to move everything around. I noticed that 24 on the left, and I don't have any other constants. So I'm going to leave that there. I'm going to go ahead and move the 8x. I'm going to subtract 8x. It was a positive 8x being subtracted to, minus that 24. So I'm going to do the opposite of 8x, right? I'm going to subtract that 8x, which again just cancels those two things out, right? 8x minus 8x is 0. Minus 24 is negative 24. 4x minus 8x would be a negative 4x, like terms over here on the right. And then finally, let's divide by negative 4 on both sides, and we will end up with x equals 6, right, for a final answer. Again, you could always plug that 6 back in, double check, make sure your two fractions are equal. But I'm going to go ahead and move on here. Let's try one more problem with that sort of bigger denominator going on, that quantity idea. And notice we've even got variables both top and bottom this time. But again, with cross multiplying, we're going to eliminate that issue, right? So I'm going to say a on the top times 8 on the bottom. So I'm going to have 8a over here. And now I've got that 9a minus 2 times 1, which technically doesn't really do much of anything, right? 1 times that quantity. I could really just get rid of that. And I really have 9a minus 2. In that case, perfect time again to get our variables together. Because they're on the opposite sides of the equal sign, I'm going to cancel away my 9a by subtracting. I'm going to move that 9a to the left. 8a minus 9a is negative a. Right? They're like terms, so I just add the coefficients. 9a minus 9a is 0. Minus 2 would be negative 2. And finally, divide by negative 1. Right? Get that a completely by itself. Negative divided by negative becomes positive. And negative 2 over negative 1 is 2. Great way to solve that problem there. Now you might recognize this printer problem from the previous video. It's a great proportions problem. Let's go ahead and look at it as a cross multiplying problem this time. So a printer can print 54 color pages in 3 minutes. And again, a great way to look at that is pages per minute. So I can say that that's 54 pages in 3 minutes. Now technically that does reduce, but I'm going to go ahead and leave that there for now. How many color pages? Well, again, pages are on the top, so let's call that X. X on the top. Can we print in 13 minutes? And again, this looks like a great opportunity to cross multiply, right? Proportion, fraction equals fraction. So we're going to say 3 times X is equal to 54 times 13, right? And now we would have to multiply that out. But in that case, the next thing I'm going to do is go ahead and divide by 3. I think this is a great opportunity again to notice 3 goes into 54. That's 18 times. Because remember, division and multiplying, I can kind of do whatever order I want, right, if I really want to. Got that commutative property working to our advantage. And associative property as well. So 54 divided by 3 would have been 18 because it was multiplication. I don't have to divide both parts. And now 18 times 13, right, is 234. And again, X was pages. So we're just going to call that pages. So pretty easy way to solve even those easier proportions. Cross multiplying just helps you stay organized. Go ahead and read through the details here. I'm going to go ahead and get started on it to save a little bit of time on the video. But if you want to pause and read through the details, go right ahead. The idea is, though, on a map, 1 inch is going to be related to 12 realistic miles in real life. Right? And on this map that we had, we're saying that Valley City and Fargo are going to be measured at 5 inches apart. Well, if 1 inch was on the top, then I'm going to put 5 inches on the top as well. And what I want to know is, what's the actual distance? Well, again, actual distance would have been the miles. 12 miles was on the bottom, X miles is on the bottom. If we do a little bit of cross multiplying real quick, X times 1 is X, and 5 times 12 is 60. I would say that in real life, Valley City and Fargo are going to be about 60 miles apart there. Let's do the same thing with Bismarck to St. Cloud. According to this, in real time, right, real life, they're 328 miles apart. Okay. How many inches apart would they be on the map? Well, again, our map says it's 1 inch is to 12 miles. So we can set that equal to, this time we know the miles, right? So we know the 328. And our variable is going to be on the top. I'm trying to find the inches, right? Well, again, same idea. Now, normally I'd try to work down the page, but I'm going to run out of room real quick. So let's go ahead and cross multiply here. But notice my arrow. 1 times 328 would be 328 is going to be equal to 12x, right? I'm going to multiply here and I'm going to multiply there. And now if I just divide by 12, they'll cross multiply and divide this time. And I'm going to continue working to the right. X equals, again, 328 divided by 12 is going to be 20, was that 24? So 88. I might have to dig out the calculator for this one. I'm thinking that this is 27 and a third. But again, may want to have to dig out the calculator on that one. They aren't always going to come out nice and even. Again, we could probably reduce our fractions down a little bit there. 4 goes into 328. What is that? 82 times. So 82 divided by 3. 3 goes into 8 twice. And leaves us 22, which I would believe 7 with a leftover third. I'm thinking I'm in pretty good shape. Now, you don't have to do that all in your head. You can, of course, use a calculator, but don't round off those decimals if you don't have to. I'd rather leave that as 27 and a third there. Hopefully that helps you again with proportions. Cross multiplying is a great way to approach this stuff. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.